So, hello everyone, and welcome to the Math Heist. Today we are gathered here to solve this quick and simple problem from algebra. And the problem statement is we have got three equations in x, y, and z, and then we have to find the largest possible value for this product x, y, z, and then we have to represent it in the form of a plus b root c upon d, where of course c is a square free integer and a, b, d all three are integers, and the GCD of ABD is 1, and hence we have to compute this sum, which is a plus b plus c plus d. So we proceed by first letting x, y, z as p, because we have x, y, z common in all these three equations. And also note that if we take a common from, we can take something common from all of the three equations. We can take common x from the first equation, we can take a y common from the second equation, and we can take a common z from the third equation. So after doing all this and taking p to the RHS, wait a minute, we have x into 1 plus y is equal to 1 minus p, y into 1 plus z is equal to 2 minus p, and z into 1 plus x is equal to 4 minus p. So let's just simply multiply these three equations, and this step is obvious since after multiplying we will also get another xyz in the LHS, which we have to find out. So xyz into 1 plus x to 1 plus y into 1 plus z is equal to 1 minus p into 2 minus p into 4 minus p. So this was p, and let's let this term out here to be q. So we let 1 plus x into 1 plus y into 1 plus z as q. So we get our first equation as p into q as 1 minus p into 2 minus p into 4 minus p. Okay, cool. But we need to find another equation in terms of p and q, since for solving an equation in two variable we need we need two equations. So we can get this second equation by simply expanding this q. So we get q as 1 plus x plus y plus z plus xy plus yz plus zx plus xyz. You can also remember this as an identity because it's a very standard and useful one. But anyways, now we have to relate this in terms of p. So we had our original equations as these. So if we simply add all of them, we will get x plus y plus z plus xy plus yz plus zx plus 3xyz is equal to 1 plus 2 plus 4, which is 7. And this was p. So we have x plus y plus z plus xy plus yz plus zx is equal to 7 minus 3p. So we can substitute this in this. So we will get q is equal to 1 plus 7 minus 3p, and xyz is again p. So we finally have our second equation as q is equal to 8 minus 2p. So we have got our two equations and we just have to solve them. So we put this second equation in 1. So 1 and 2, we get p into q was this term. So let's take a 2 common from the outside here. So 2p into 4 minus p is equal to 1 minus p into 2 minus p into 4 minus p. We can cancel this 4 minus p from both the sides with the possibility of p is equal to 4, and we will have to check later whether it's the maximum possible value of p or not. But for now, 2p is equal to 2 minus 2p minus p plus p squared. So we get our quadratic as p squared minus 5p plus 2 is equal to 0. So on solving it, we get P as 5 plus minus under root 17 over 2. We have simply used the quadratic formula here. So the set of all possible values of P is this. P can be 4, P can be 5 minus root 17 by 2, and P can be 5 plus root 17 by 2. Obviously, this cannot be the maximum possible value. We just have to check between 4 and 5 plus root 17 over 2. And on some minor calculations, we will see that this is actually the maximum possible value because root 17 is 4 point something and this will become 4.5 something. So the largest possible value of P is simply 5 plus 1 root 17 over 2, and which was given to us as a plus b root c over d. So on comparing, we get a as 5, b as 1, c as 17, and d as 2, and hence we get our answer as a plus b plus c plus d as 23 plus 5, 23 plus 2, which is simply 25. And that solves our easy problem. Do like, share, and subscribe the video. Thanks.